Okay, so in this video, we're going to look at calculations on resistivity, right? We're going to look at calculations on resistivity. So the question that I have here is, what is the resistivity of a cylindrical material, wire, whose 1.0 meter length has a resistance of 2 ohms? The diameter of the wire is 0.5 millimeters. I read again, what is the resistivity of a cylindrical material wire whose 1.0 meter length has a resistance of 2 ohms? The diameter of the wire is 0.5 millimeters. So let's put the solution here, right? The question is, what is the resistivity of a cylindrical material wire? What is the resistivity? So what we're calculating for is the resistivity, and it is unknown, right? What is the resistivity of a cylindrical material wire whose 1.0 meter length? So that tells us that the length of the wire is what? 1 meters, right? 1.0 meters. So that's 1 meters. Has a resistance of 2 ohms. What does that tell us? That the resistance of this wire is equal to what? 2 ohms. Then the diameter of the wire is 0.5 millimeters. The diameter D of the wire is equal to 0.5 millimeters, right? So the question now is, what formula connects these four parameters? I have resistivity, I have length, I have resistance, and I have the diameter, right? The formula that connects this, or the formula for calculating the resistivity of a wire, of a resistor, is resistance is equal to resistivity times length all over what? Area. This formula is very important. We've looked at it before, and then we're looking at its application. So this is the formula that we use in calculating for resistivity, right? Resistance is equal to resistivity times length all over what? Area. So how do we make this resistivity the subject of the formula? Because this is what we're looking for. So this is rho over 1. If I cross multiply, resistivity times length times 1 will also give me resistivity times length is equal to rho times A will give me what? Rho A. So if I make resistivity the subject of the formula, I'm going to divide both sides by the coefficient of this resistivity, which is L. So this will be divided by length, divided by what? Length. Length will cancel out length. So my resistivity is equal to Ra over what? Over length, right? So to calculate for this question, the formula that we're going to use is resistivity is equal to what? Ra over what? Over length. So resistivity, which is what I'm looking for, is equal to the resistance of the cylindrical material wire is what? 2 ohms. So that's 2 times the area is not given, right? So we're going to calculate for the area over the length of the wire. The length of the wire is what? 1 meters over 1. So what we have here that is not given is the area. But we have the diameter of the cylindrical wire to be what? To be 0.5 millimeters. So the material is a cylindrical material wire. So the question is, what is because this A, the area here is the cross-sectional area. So what's the formula for the cross-sectional area of a cylindrical material? So the formula for the cross-sectional area of a cylindrical material, formula for cross-sectional area, cross-sectional area of a cylindrical material is equal to pi r squared. It is the same thing as the area of a circle, right? pi r squared. So from our question, we are given that the diameter is equal to 0.5 millimeters. So we have d to be equal to what? 0.5 millimeters. We cannot solve using the diameter, because what we have here, if we're looking for the area is pi r squared, right? And we have diameter. Okay, the next thing that you want to do is to look for the radius from this diameter. So what's the relationship between the diameter and radius of a circle? The relationship is radius is equal to diameter over 2. So my radius will be equal to, my diameter is what? 0.5 over 2. That will be equal to what? So I'll bring in my calculator and press that 0.5 divided by 2 is equal to 0.25, right? So that will be equal to 0.25 millimeters. So radius is equal to 0.25 millimeters. But I cannot solve using this unit, because the unit for length is meters and not millimeters. The SI unit of length is meters and not what? Millimeters. So I would need to convert these millimeters to meter. So you want to ask yourself this question: how many millimeters make 1 meter? 1000 millimeters is equal to 1 meter. 1000 millimeters is equal to 1 meter. So therefore 0.25 millimeters 0.25 millimeters will be equal to 0.25 millimeters divided by what? 1000. So 0.25 divided by 1000 will give us what? 0.25 divided by 1000 will be equal to 2.5 times 10 raised to the power minus what? 4. So that will give us 2.5 times 10 raised to the power of minus 4, right? So 0.25 divided by 1000 is equal to 2.5 times 10 raised to the power of what? Minus 4, right? And this is the same thing as 0.00025. This power of minus 4 represents the number of zeros, 1, 2, 3, 4. And then we have 2.5, which is the 25. So this and this are the same. So what we've just done is that we have converted, this is meters now, we have converted this 0.25 millimeters to meters, and that is equal to what? 0.25 divided by what? 1000, and that gave us 0.00025 meters. So our radius is equal to 0.0025 meters, which is what we've gotten here, right? So the area is equal to what? Pi r squared. That's the cross-sectional area of a cylinder, right? Cross-sectional area is equal to pi r squared. So you should know that your pi is a constant and the value is 22/7 times your r, which is the radius, is 0.00025 raised to the power of 2, right? So that's our radius. So that will be 0.00025 raised to the power of what? 2. Because what I have here is r squared. So if I multiply that in the calculator, it will be 22 times 0.00025 times 0.00025, right? So let me bring out my calculator and press that. So this will be 0.00025 raised to the power of 2 is equal to times 22 times this 22. That will be equal to divided by 7. That will be equal to So that will be equal to, everything will be now be equal to 1.96 times 10 raised to the power of what? Minus 7. So that will give us 1.96 times 10 raised to the power of what? Minus 7 meters squared. Because what we're looking for here is the cross-sectional area. So the cross-sectional area is 1.96 times 10 raised to the power of what? Minus 7. So having gotten the cross-sectional area, we cannot put it into our equation. So this is resistivity is equal to resistance times cross-sectional area over length. So resistivity is equal to 2, which is the 2 ohms, the resistance, times the cross-sectional area. We got it to be what? We got it to be 1.96 times 10 raised to the power of what? Minus 7. So 1.96 times 10 raised to the power of what? Minus 7. Divided by what? The length. And the length is given as what? 1 meters. So resistivity will be equal to 2 times 1.96 times 10 raised to the power of minus 7. 2 times 1.96 times 10 raised to the power of minus 7. That will be equal to 3.92 times 10 raised to the power of minus 7 divided by 1 is still the same thing, right? So that is 3.92 times 10 raised to the power of what? Minus 7 divided by 1. So my resistivity will be equal to 3.92 times 10 raised to the power of minus 7 ohm meters. Ohm meters, right? So this is our answer. So why is the unit ohm meter? It's very easy. Resistivity is equal to RA over what? Length. Your resistance is measured in what? In ohms, right? Area is measured in meters. And if we represent that, that is M times what? M. M times M over length in meters. That is what? M. So M will cancel out M. Ohms times meter will give us what? Ohm meter. So that is why the unit for resistivity is equal to what? Ohm meter. So this is very important. You can be asked in an exam, which of the following is the unit for measuring resistivity? It is ohm meters, right? So this is just all about this question. It is very simple and straightforward.